Hey guys, welcome back to my third part of my gas laws video. I will be doing Gay-Lussacs law. In this video, we'll be talking about what it means, the relationship, and we'll be doing two more practice problems as per usual. Okay, so here, Gay-Lussacs law states the relationship between pressure and Kelvin temperature at constant volume and at pressure and Kelvin temperature are directly proportional, and which means as pressure goes up, temperature goes up. As pressure goes down, temperature goes down, which is exactly like Charles's law, except instead of pressure being constant, volume is constant. And the graph would look like this. It's another direct direct relationship. As pressure goes up, temperature goes up, direct. And the equation for Gay-Lussacs law is P1 over T1 equals P2 over T2. Also, another thing to note that isn't on the slideshow is as temperature increases, particles move faster, or kinetic energy increases, meaning there are more collisions, which causes greater pressure. That is something that you should know, that may or may not be important, but I know that for some of the explanation questions, you'll need outside information, and that would be one of the points you should use. Okay, so now we'll move on to the practice questions. Okay, so for the first question, we have a container, a container of hairspray with a pressure of 4.0 atmospheres at a room temperature of 25 degrees Celsius is thrown into a fire. If the temperature of the gas inside the aerosol can reached 402 degrees Celsius, what will be its pressure? So for this, we know the formula is P1 over T1 equals P2 over T2. So let's see. Here we have, this is our original pressure. This is our original temperature. This is our second temperature. So we are looking for the second pressure. So to set it up, we will do 4.0 over 25 plus 273 is 298, I think. 298 Kelvin equals pressure 2 over 402 plus 273 is 675 Kelvin. And again, as always, when you have a proportion, two fractions that equal to each other, you cross multiply like this, in case you haven't seen the last video, or the last one. So 4.0 times 675 is 2700, and then 298 times P2 is 298 P2. That's really messy. 298 P2. Then you divide both sides by 298. then P2 equals, it says significant figures, which is 3, this question. No, it's 2, because this is 2 significant figures, so it'd be 9.1 atmospheres. Does that make sense? I hope. Maybe. Okay, so here we have a second question. I'll read it out loud. Then I'll pause the video, and you should pause the video too, so you could try to solve it on your own. And then I'll set it up. Well, I have my recording paused, and then when I unpause it, the setup should pop up, and then I'll show you the answer. Okay, so we have a 10-liter container of helium gas has a pressure of 250 torr at 0 degrees Celsius. To what Celsius temperature does the sample need to be heated to obtain a pressure of 1500 torr? So we're looking for the second temperature in this, right? Okay, so knowing that, try to solve. Okay, so here's what I have set up. 250 over 273 equals 1500 over T2. So I forgot about this, but it says a 10-liter container. The reason why I didn't include that in my setup here is because this is volume. And if you remember, when solving these problems, volume remains constant. So on both sides, the volume would be 10 because it doesn't change. And so we will not add that into our equation. So we just have 250 torr at 0 degrees Celsius or 273 Kelvin equals 1500 torr over T2. And if we solve that, we get 250 T2 equals 409,500. And if we divide both sides by 250, we get we get 1638 Kelvin, but it's asking to what Celsius temperature. So now we need to convert this by subtracting 273 from it to get 1365 degrees Celsius. Thank you for watching this. I really appreciate this, and I really enjoy helping people at chemistry, and I really hope that these videos do help someone eventually. So thank you for watching. This was Gay-Lussacs law. Next time I'll cover combined gas laws.